Movement of electricity from a distribution point to a piece of equipment. Primary job. Got to get it there somehow. Secondary job, equally as important. It's a primary heat sink for your system. Second conductor in your system. Your grounded conductor, formerly known as the neutral. Primary job, pathway for unused current. Pathway for the recovery of unused current. Grounded conductor. Secondary job, equally as important. Magnetic synchronicity within your system. Magnetic synchronicity within your system. This is to stop your magnets from fighting. It yielded a term when it's working. You may recognize it. Unbalanced current. The only thing that should remain in your system, if it's doing its job, is what it can't magnetically balance out. And we refer to it as, you know, Victor, you can't check nothing but your unbalanced current. You're right. Because when it's doing its job, that should be all that's left. Because you may have a system that has loading of 80 amps of return current, but when it does its job, you may find out at that MDP or that panel board in distribution, there's only 5 amps left on that neutral up there. That's because it was performing its job, magnetically balancing out that return current through those magnetic fields. And I can prove it. If we run multiples in a system, we can't go all A's, all B's, all C's, all neutrals. We got to go ABC neutral, ABC neutral, ABC neutral. Why would we do that? So those magnetic fields don't fight. They have to be synchronized and balanced out. And that neutral conductor does that grounded conductor. Have you noticed on SE and USE, the phase conductors are always wrapped around it? Have you noticed on your 6-3 a lot of time, guess what? It's twisted. That's because both magnets are present. We need those twisted around that grounded conductor so it can balance out those magnetic fields. Otherwise, those two magnets will fight. You ever tried pushing magnets around on a table? That's what would happen in your system. One conductor, 2 jobs. The next conductor in your system, your bonding jumper. Primary job, movement of heat between your enclosures, giving your enclosures continuity. Primary job. Secondary job, equally as important. We have a condition that occurs that is catastrophic. We call it losing the neutral. When we lose the transformer neutral, our systems invert to their highest voltage, and that is destructive to equipment. So since that condition can happen, wouldn't it behoove us to have a backup? That'd be a good idea to have a backup, wouldn't it? Well, guess what? That's the second job of the bonding jumper. The second job of the bonding jumper is to be the backup for the grounded conductor. Now understanding how it works is very important, because now in illustration, this is going to be observable of why we need to know how things work. When somebody calls and says they've lost the neutral, or they see those conditions, it's usually a homeowner or a business owner. They see the anomalies, they go to the panel board, load center, reach up and grab that D-ring, and they get hit. Oh, oh, that hurt. See, they were looking for a breaker. That thing's hot. You need to come over here. My panel board just bit me and I got light bulbs just blowing up everywhere. Sound familiar? Now you go there. Don't touch that panel board, it'll bite you too. It's got active return current on it. Now here's how you check it. Go find you a ground point. It can even be the electrode system. Don't touch it because it's active. Glove up. Get you a conductor under that acorn. Set your reel wire on that flat blade. Spool it off till you get in front of it. Clip it, strip it, tape it on your black lead. Now turn it on voltage. Reach up with your red lead and touch one of the mounting screws going through the dead front. If that's a single phase system, 120 to 40, and it reads 120, you've lost 50% of the neutral. If it reads 60, you've lost 25%. If it reads 180, you've lost 75%. If it reads 240, you've lost it all. Now I'm going to show you why that's relevant. I already told you, I worked for the utility. I was licensed. I got my heart broke. I found out what they think about us. They call you installers. You call me an installer, I'll drag you in that bathroom and beat the stuffings out of you. I know exactly what I work on. How many of you knew how your system worked before you walked in here yesterday? You see my point? That's why when you call them, you know the condition. They teach their techs to say this. You've had it said. Hey, I need you over here at this address. You've lost your neutral. They'll say, go check your system. That's hurtful, isn't it? Go check your system. It's intentional. They know what I know. You didn't walk in the door yesterday knowing how your system operated. Jobs as a conductor or anything else. Now let me show you the difference after today. I need you at 42 Crestmont. My bonding jumper system is activated. I've got 120 volts on my enclosures, which tells me you've lost 50% of your transformer neutral. Matter of fact, I'm standing outside now, and there's a great big limb laying on the ground next to your transformer pole. I suspect that's what fell out of the tree and pulled half the strands out from under that buckle. When can I expect a tech over here? Trust me, you will not hear the words, go check your system. They'll say, we'll have a tech there in about 10 minutes. They know it's an unsafe condition. And they'll hang the phone up and key their mic and say, Tech 541, you need to get over to 42 Crestmont and make sure you got what you need on the truck to re-terminate a transformer neutral. And be advised, you have a qualified individual on site that knows exactly how systems work. Who you want to be. Who you want to be. You see the difference? One conductor, two jobs. Primary job, keep the heat even in the system. Second job, back up that grounded conductor so that we can still evacuate unbalanced current, even if it's done in a slower migration. Next conductor in your system, your grounding electrode conductor. Primary job, 0 on the ruler. Ground reference. You ever tried to measure anything with a broken ruler? You think you can do it. That thing got 3 inches missing. Let me see what I can do here. -3, +3, and then pretty soon you go, whew. Let me go get me a ruler that works. How many of you ever gone in a building and found dissimilar voltages from one end to the other? Got nothing to do with the equipment. Because the first thing you start doing is tearing everything apart. Let me go find this. There's a culprit somewhere. What you should have done is gone right back out front to the service, climb behind all them bristly bushes, and start looking for that electrode system. Because you just lost your ground reference. Means you lose your 0 on the ruler. All electricity is made with coils of wire. I can prove it. Everybody in here's put in a transformer. You get it unboxed, get it unbolted from the pallet, tear open the instructions. It says, step 1, ground me. Not step 2, not step 3. Step 1 says, ground me. You know why? Those coils of wire around that big block of metal, when you put energy to them, they start doing this. Whoa, 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 whoa. You put a ground on them, they go, whoa. Not whoa, whoa, whoa. It gives your coils of energy something to measure off of. 0 on the ruler. I'm wound to be 480 volts. Without my ground reference, I don't know what I need to do. I got this much wire. Let me start hunting and pecking. I can't find 480. Let me go to 460. Let me go to 490. Oh, there it is. That's what 480 feels like. It's ground reference. It's primary job. Wouldn't it behoove us to have a backup? Why do you think we take a number 4 to the foundation? Primary job. Ground reference. 0 on the ruler. Secondary job, equally as important. Protection of the transformer. So every time you have a fault, you don't blow the bayonets or blow the transformer up. That's why you need to put as much emphasis in an electrode system as you do the pride of building the system. Protection of the transformer. I'm actually going to show you how that works when we start doing bonding and grounding in a minute. How much you want to bet it's got something to do with 20%? Last conductor in your system. Your equipment grounding conductor. Equipment grounding conductor. One conductor, two jobs. Primary job, this is strictly the work of Mike Faraday. Isolation of harmful current. Secondary job, equally as important. Removal of cloud impedance from your system. removal of cloud impedance from your system. Now you have every job of every conductor within your system. Now when you see those conditions, yes sir?
What was the primary job now?
The what?
The primary job.
Of the equipment ground was the isolation of harmful current. Isolation of harmful current. So you can touch equipment without getting hurt.